The representation of memristor model in MATLAB and Simulink environment, prepared by Sanjar Askarova and Bakhtiar Akhmetov. The main goal to evaluate the memristor through modeling it in MATLAB and Simulink. Previously published papers about memristors and their features are used as the foundation of the work. Initially, there were three basic passive elements: resistors, inductors, and capacitors in the modern analog electronics. However, based on square symmetry, another element called memristor or memory resistor was presented in 1971. It contains of a direct connection between flux and the charge. In other words, memristors show that resistance is dependent on a passing charge. As a result, it can be seen that memristors do not need any energy to keep data in terms of recording and reading. Therefore, the fourth passive element is able to hold information about the net amount of charge gone through. The resistance of memristor can be varied constantly with current within certain limits. The first memristor was built by Hewlett-Packard Company in 2008. Its nanopart was made of titanium oxide with size of from 10 to 30 nanometers, held between two platinum electrodes, as shown on the picture. The titan layer doesn't have oxygen atoms that make it to behave as semiconductor. The another part acts as insulator. The main functioning principle of memristor is that the semiconductor layer's width changes just when current passes. There are four main equations that describe memristor. On the picture, D is the total thickness of memristor, while W is the width region, which is a function of current flowing through. The exciting voltage is the first equation, where R sub mem the total resistance of doped and undoped region. X is the ratio of W over D. Second equation is the dynamic state equation of the current that shows the dependence on X. Mu sub V is a constant and it is a dopant mobility. The next equation is the total resistance equation. Here R on corresponds to the case when W is equal to 0 and R off is when W is equal to D. The last equation called the Windle function. The first and fourth equations show the mathematical model of memristor. Simulink environment is a better option when the memristors is to be modeled as an element of complex system. Below we can see the equations that were shown before that were used for modeling. Simulink offers modeling the form of the input and output relationship. However, since the memristor is not possible to be represented as two-terminal element, there is another way to model it. It is shown as a device with the input of voltage and output of current. Below on the picture we can see that the current is a function of voltage. There is also a Simscape block library intended for multi-domain modeling of physical systems. It also gives opportunity to simulate systems of different engineering fields. Finally, there is a reference list. Thank you for your attention.